This video is on Unit 7, Chapter 14 on regression, lesson number 1, Scatterplots, linear regression. In this lesson, we are going to focus on just linear relationships in data. So a scatter plot from probably Algebra 1 shows the relationship between two variables. We're going to look at these three different sketches of three different scenarios. So a positive correlation is data that has a positive slant to it. So if I draw a line through the middle of all these dots, you can easily see that the slope or the slant of that line has a positive slant, thus positive correlation. The next one says negative correlation, and the reason for that is because if you look at the dots and we draw a line through the center of all those dots, the slant or the slope of that line is negative, making that a negative correlation. The last one is called no correlation because there's no relationship in any of those dots. Now, when we gather data or when data is gathered, you're looking for there to be some kind of a relationship. So you want it to have a positive correlation or a negative correlation. The no correlation means that there's no relationship in the data. So line of best fit or regression equation. Regression analysis is a statistical method that examines the relationship between two quantities of interest. The two quantities of interest are your independent, which is your x, and your dependent, which is your y, variables. Using regression, we can write an equation for the line of best fit or the regression equation. Both of those things are the same. So sometimes you might hear me call it line of best fit, but most of the time you're going to hear me call it a regression equation. In Algebra 1, you would have studied this as line of best fit. And in Algebra 2, we refer to it more as a regression equation because we don't focus on just linear data. Some of our data might create a parabola, creating a quadratic relationship, or a cubic relationship, or an exponential, or a logarithmic. So we have different regression equations that we're going to look at in this chapter. The line of best fit or regression equation can then be used to predict the value of a variable given the value of the other variables. So the purpose of these regression equations is so that we can predict what might happen in the future. The line of best fit refers to a linear relationship between variables, while the regression equation can refer to any relationship, whether linear, quadratic, cubic, or exponential. The correlation coefficient R indicates how well the data fits a linear model. It is a number that falls between -1 and +1. The closer to 1 or -1, the stronger the correlation, and then the closer to 0 the correlation coefficient is, the weaker the correlation. So that last bullet is extremely important, but you probably didn't understand a word that I just said. So I'm going to go back up to my pictures and kind of give you an idea of what this means here. So the correlation coefficient is an R, and when we look at no correlation, the correlation coefficient is going to be 0 or close to 0. For our positive correlation that I've got drawn, the correlation coefficient will be close to a +1. Okay, this one's probably a 0.95. I'm guessing. It's just a total guess, but it's a decimal that's close to a +1. Now, a correlation coefficient close to 1 is strong, and it means that the data has a very strong relationship. For negative correlation, according to what I have drawn here, the correlation coefficient for this one is going to be close to -1. And again, I'm just going to guess and say this one might be something like -0.95. The further the dots are from each other, the further away from 1 or -1 we get. So the closer they are together. So let me give you an idea. So if I have dots that are extremely close together, and you can easily see that line. This is a correlation coefficient that would be closer to 1. So this one might be 0.99. Let's move on to your steps. So this last thing on this page are the steps that you're going to go through to do regression, linear regression calculator steps. Using the graphing calculator, we can find the regression equation, which creates the most precise equation possible. You must turn on Stat Diagnostics and Stat Wizards, which is found in Mode. So when you come to class to work on the assignment portion of this, you're going to need to come back to this section of your notes with your graphing calculator and follow this information here to work the problems in the assignment. So let me show you where Stat Diagnostics and Stat Wizard is. So if you go to your calculator and you go to Mode, down towards the bottom of this screen, you're going to see Stat Diagnostics. Now, my Stat Diagnostics is already on. If yours is off, you're going to arrow over the word on and you're going to hit enter. My Stat Wizard is also already on. So if yours is not, you're going to hover over the on and hit enter. Then we can exit out of that and we are good to go. So there's a set of instructions for entering your data, and then there's a set of instructions for finding your line of best fit. I do want to show you one more thing before I get started. If you go to second y equal, you may want to write this down. Second y equal gives us options for statistical plots. So I'm going to turn on plot number 1. So second y equal, enter. I'm going to turn this one on. The type is this very first one because this is a scatter plot. The x's are in L1. The y's are going to end up in L2. And I'm going to have marks on my graph with a little plus, and they're going to be magenta color. So second y equal, enter, and you can turn on your stat plots. Okay? Now, let's go back to the notes. To enter your data, you're going to hit stat and then enter, which is edit. You're going to enter all of your x's into L1. Your y's are going to go into L2. To find the line of best fit, we're going to hit stat, arrow over to calc. We're going to choose number 4, which is linear regression, and then we're going to hit enter. We may have to enter twice. So let's look at the next page in the notes here. It's an example number 1 for linear regression. Number 1 says the table below shows the number of people and suitcases on 8 airplanes. So I will tell you up front, the people are going to be your X. The number of suitcases is going to be your Y. The reason for that is because the number of suitcases is dependent on the number of people that you have. So your Y variable is your dependent, your X is your independent. So we need to find our regression equation. To do that, we're going to go to the calculator and we're going to put all of the X's into L1 and the Y's are going to go into L2. So go to the calculator, click on stat, click on edit. I have information here. You jot this down in your notes as well. So to clear information out of your lists, to clear, arrow up, hit clear, and then enter. Again, in your notes, write down to clear lists, arrow up, hit clear, then enter. All right, so now we can put our X's in. We're going to hit 63, enter. 115, enter. 153, enter. 192, enter. 224, enter. 297, 331, and 375. 375. Now we're going to arrow to the right for L2. I'm going to use the Y's, 112, 209, 278, 302, 379, 500, 586, and 712. You're going to hear me say this a lot, but what you're going to want to do is take just a second or two to go through each of the lists and make sure that you have entered everything correctly. It doesn't take long, and you definitely want to make sure you do that and catch any mistakes here before you come up with the wrong equation. And when you come up with the wrong equation, your predictions are going to be wrong, and it's going to affect everything. So now what we need to do is we need to click on Stat, arrow over to Calc, and we're going to select number 4. And I'm going to add another thing to your notes. I'm going to add one more thing. To store your regression equation, on this screen, we can make it so that the regression equation is stored in our calculator, which is going to help us later. So the X lists, the X's are in L1, the Y's are in L2. The frequency list does not matter. When we get to the store regression equation, write this down. You're going to hit alpha, trace, enter. So what I've just done is I've told my calculator, whatever equation you come up with, I need you to store it into Y1. And you'll see why that's important here in just a second. I'm going to arrow down and I'm going to hit enter. So what you have here is all of the information, important information. You need to ignore the R squared here. So R squared is going to come into play when we talk about quadratic and cubic and exponential regression, but it does not affect linear. Your correlation coefficient is the R. So R is equal to 0.992. 0.992. So that's an actual question on our worksheet here. Part B says state the correlation coefficient and explain. So the correlation coefficient is 0.992. Now, 0.992 is extremely close to the number 1. So what that means, and because it's a positive, is we have a positive, strong correlation. And basically, y'all, what that means is that the relationship between the number of people and the number of suitcases has a very strong relationship. They are directly related to one another. There's a very strong relationship between those two things. Now, as far as the regression equation, I'm going to go back to the calculator, and I want to point out right up here at the top says y equals ax plus b. That's your general equation, and all you have to do is plug in the a and plug in the b. A is equal to 1.834. So I'm going to write that. A equals 1.834. The B equals negative 16.498. And again, your equation was y equals ax plus b. So we're just going to plug that in. Y equals 1.834x minus 16.498. So there's the equation. Part C says predict the number of suitcases on an airplane with 500 people. With 500 people, 500 is your X. So there's two ways we can do this. We can plug in 500 into our equation. So I'm going to exit out of this. 1.834 times 500 minus the 16.498. And I'm going to say about 901 suitcases, approximately. Okay, so that would be the answer for part C. The steps for the rest of these are identical. There are times when we're going to predict the year. Those are things I feel like we need to practice together. But that is your video for Unit 7, Chapter 14, Lesson number 1.